morning, mathematicians. We're on Unit 5, Lesson 7. We're going to be connecting tables, equations, graphs, and stories of functions. Yeah, it doesn't get any better than this. I mean, seriously, it really doesn't. Except for this joke that one of you sent in. What did 6 say to 7? Will you be my +1? I love that. We are on page 57 in your workbook and goes on to 58. So you might just want to look at this slide for now. Here are 3 different ways of representing functions. How are they alike and how are they different? We've got the equation y equals 2x, the graph of a function, and a table of a function. Okay, we've got a lot of different answers from you, but most everyone hit on the fact that you can show functions in a lot of different ways, and they all have some sort of input-output pair. So in this equation, our input is x here, that's our input, and our output is our y here. In our function, our input is here and our output is here. The top row here is our input and our output is here. So 3 different ways to show it, but they're all functions with input-output pairs. So let's look at these 2 different ways of representing comparing temperatures. Now, it's important that you understand this refers to city A and this refers to city B. Okay, so the graph is for city A and the table is for city B. So take a couple minutes and answer those 3 questions based on the graph of city A and the table for city B. So which city was warmer at 4 p.m.? On the table, I look here, and this is about 57 degrees. And here is 4 p.m. for city B, which is 62. So this is definitely city B. Which city had a bigger change in temperature between 1 p.m. and 5 p.m.? So here's 1 p.m., here's 5 p.m. So here we're at about 50.5. Here we're about 58. So for city A, the change was 58 minus 50.5, which is about 7.5 degrees. For city B, I'm going to look at 1 o'clock to 5 o'clock. So we had 82 versus 58. 82 minus 58, I'm looking for the difference, I'm doing a subtraction problem, is 24 degrees. So B dropped by 24 degrees. You wouldn't have even necessarily had to do the math on that. You could tell 82 to 58 was going to be a bigger drop. So again, it's city B. How much greater was the highest recorded temperature in city B than the highest recorded temperature in city A during this time? Well, the highest is going to be right here and right here. So it's 82 from city B minus 59 from city A, which is 23 degrees. And number 4, compare the outputs of the functions when the input is 3. So here's my input of 3, and that is at about 54.5 as my output, and here is 75. So city B is about 20.5 degrees warmer than city A. All right? So which representation do you think was better for identifying the highest recorded temperature? Raise your hand if you think it was the graph. And now raise your foot if you think it was the table. I saw more hands than feet, so I'm really thinking that you were agreeing with me that the graph made it super easy to identify which was the highest. Okay, we're going to compare some volumes. So the volume of the cube with edge length s centimeters is given by the equation V equals S cubed. This is the cube here. Okay, and the volume of the sphere is here. The sphere. So you're going to use these two different representations to answer the questions. All right, so is the volume of a cube with the edge length s equals 3 greater or less than the volume of the sphere with the radius of 3? For the cube, you'll do 3 cubed, which is 27. And you can look for number when you go to 3 on the graph, it's more than 100. So obviously the cube is less than. For number 2, if a sphere has the same volume as a cube with edge length 5, estimate the radius of the sphere. So the cube is going to have 125 cubic centimeters. Now if we look at 125 on the graph and drop it down, we would get to about 3.1 centimeters for the radius of the sphere. And now we're going to compare the outputs of the two volume functions when the inputs are 2. For the cube, of course, we'll have 2 cubed, which equals 8. And for the sphere, if we look when the input on the horizontal axis is 2, that's at about 35. So the sphere's volume is about 35 cubic centimeters. Okay? All right. It is time for a dance break. back to the math. So Elena's family is driving on the freeway at 55 miles per hour. Okay, that's a constant speed, so that gives us a lot of information. Andre's family is driving on the same freeway, but not at a constant speed. The table shows how far Andre's family has traveled, D, in miles every minute for 10 minutes. Okay, so here we've got in our time in minutes, and here we've got our time in hours. As we compare these two different functions that are in two different formats, we want to make sure that we have the same units. So the first question asks, how many miles per minute is 55 miles per hour? So 55 miles in 1 hour times 1 hour is 60 minutes, right? Okay, my hours cancel out, and I will do 55 divided by 60, and I will get 0.92 miles per minute. Okay, so use that 0.92 miles per minute to answer the questions 2, 3, and 4. All right, so who had traveled farther after 5 minutes? Super easy to find for Andre. He went 5.1 miles in 5 minutes. Elena, not that difficult to figure out. We're just going to do 0.92, and this is Elena, times 5, and that's going to give us about 4.6 miles. For 10, here we are at 10. Okay, and let's do Elena's. For 10, also pretty easy because we're going to do 0.92 times 10, and we're going to get 9.2 miles. So Andre traveled farther in 5 minutes because he went 5.1 miles, and Elena traveled farther in 10 minutes because she went 9.2. How long did it take Elena's family to travel as far as Andre's family had traveled? After 8 minutes. Okay, so after 8 minutes, Andre had traveled 7.4 miles. So 7.4 is the distance, and we know that Elena's family was traveling 0.92 miles per minute. 7.4 divided by 0.92, which would be 8 4/100 of a minute. And for both families, the distance in miles is a function of time in minutes. Compare the outputs of these functions when the input is 3. Well, let's look. When the input is 3 here, Andre's family went 3 miles. For Elena, 3 times 0.92 is going to give us 2.76 miles. So Andre's family went 24/100 of a mile further in 3 minutes. Okay, so even though we have different representations, we had a description of how Elena's family traveled. We had a table of how far Andre's family traveled. We converted what we knew about Elena's family into miles per minute. And at one point, we even wrote a new expression here for how far Elena's family traveled. And then we could make comparisons about the outputs for different inputs for Elena and Andre and their families. Which brings us to the big idea. Functions are all about getting unique outputs from inputs. For each way of representing a function, we had equations, we had graphs, we had tables, we had verbal descriptions. We can determine the output for a given input. And what's important to realize is that we can compare the different inputs and outputs even when the functions are displayed in different ways. So write this big idea in your notebook. Do the exit ticket so I can see how you're understanding things. And then your homework is going to be practice pages in the workbook, pages 63 to 65.